In this final video, we're going to solve logarithmic equations again, like the last video, except this we are actually going to look for these extraneous solutions to see if we have any. Extraneous solutions will be solutions that give us arguments for logs that are negative. So same kind of technique here. We have log base 12 on the left-hand side of this equation, and a plus here. So we need to write this as log of a single quantity. So we've got log base 12 of 12x times, because of this addition, times x minus 1. Well, hold on, 12x times x minus 1 equals 2. Now, so I haven't reviewed this, so I'm just thinking out loud a little bit. And the way we want to solve this is, earlier in the videos, we will rewrite this as an exponential equation. So log base 12 of this whole argument equals 2 can be rewrite as an exponential. The reason we do this is because we only have a log. We can't do 1-to-1. We don't have log base 12 on both sides. So rewrite as an exponential equation. So this is 12 to the 2 power is equal to 12x times x minus 1. And now we're going to go about solving this. We've got 144 on the left is equal to 12x squared minus 12x. This is an exponential equation, quadratic equation now, so we're going to set it equal to 0 and put all my variables on the left. Just feels more comfortable. And subtracting 144, I should be moving the 144 to the right. That's equal to 0. Divide out 12, that's a common factor, so we have 12 times x squared minus x minus 12 equals 0. And so this 12 doesn't really count. We just need to solve this part here. I'll just go ahead and keep the 12 out there, but we have equals 0. We bring in the x, factors of negative 12 that add up to be negative 1. So negative 4 and 3 work. Plus 3. So our solutions to this quadratic equation are x equals 4 and negative 3. Now, here's the key. Excuse me, here's the key. The negative 3 is, if I plug in negative 3 for this expression here, I'm going to be taking log base 12 of negative 3 times 12 is negative 36. I can't take a log of a negative number. Moreover, over here, if I plug in negative 3 minus 1, that's negative 4. Log base 12 of a negative 4, I can't do that. So this negative 3 is extraneous. And the answer is just x equals 4. Hope that makes sense. Let's go ahead and look at this this one over here. We have a minus, so we've got to we can combine these two, this difference of logs to be a log of a quotient, 6y plus 2 over y plus 1 equals natural log of 2y minus 1. Now, they're both natural logs, so we can use 1 to 1. So we have 6y plus 2 over y plus 1 is equal to 2y minus 1. And sort of like before, you know, we can do a cross product, however you want to think about this. Multiply both sides by y plus 1, one way or the other. On the left, we have 6y plus 2 equals y plus 1 times 2y minus 1. We'll simplify this out. 6y plus 2 equals 2y squared minus y plus 2y minus 1. Now we need to get everything on one side. So let's move all of these terms over to the right-hand side. So we have two, I know I'm kind of violating some principles, but we're going to take, we have 2y squared, and then we have minus y plus 2y minus 1, and then I'm going to subtract these other left-hand elements from this right-hand side. So minus 6y minus 2, and that's all equal to 0. Basically, I'm subtracting all of this stuff off from the left and over here to the right. Just feel comfortable with everything on the left. So I've got 2y squared. Now, minus y plus 2y is y. Y minus 6y, that's minus 5y. And then I have minus 1 minus 2, so that's minus 3 equals 0. And we'll see if this factors. Bring 2y into both of these factors. We are looking for factors of 2 times negative 3 or negative 6, which add up to be negative 5. We had this combination a little earlier. This is minus 6 and plus 1. So minus 6 plus 1. This has a common factor of 2. So what we have is y minus 3. That's 2y plus 1 equals 0. This part right here. That wasn't complete yet. But at this point now, you can see we can read out the solutions. Possible solutions are y equals 3 or negative 1/2. Now we need to check, does that work? Well, 3, if we just think of 3, 6 times 3 is 18 plus 2. Can you take a natural log of 18 plus 2 or 20? Sure. 3 plus 1, that's 4. You can take a natural log of 4. That's a positive number, sure. 3 times 2 is 6, minus 1 is 5. Natural log of 5, that's a real number. But the negative 1/2, let's just, the negative 1/2 would work fine here, but not here. 6 times negative 1/2 plus 2 is going to be 6 times negative 1, negative 3/2. 2 minus 1/2, or 4/2, it's negative 3/2. This would be a negative number, negative 18 over 2, which is negative 9. Negative 9. That's not going to work. In this, negative 1/2 won't work. Bad. And so negative 1/2 is extraneous. Extraneous is what we call that. Just our algebra gave us this value, but because of all the transformations, it doesn't really work. So our answer is y equals 3 and only 3. And this is where, looking at a graph, you would see that these two, the left hand and the right hand side, have one point of intersection.